Lesson 7.2, Finding Complex Solutions of Polynomial Equations. Essential question: what do the fundamental theorem of algebra and its corollary tell you about the roots of the polynomial equation p of x equals 0, where p of x has degree n? They tell you that the equation E, boy, I tell you, the equation has exactly n roots. Exactly n roots. Investigating the number of complex zeros of a polynomial function. You have used various algebraic and graphical methods to find the roots of a polynomial equation p of x equals 0, or the zeros of a polynomial function p of x. Because a polynomial can have a factor that repeats, a zero or a root can occur multiple times. The polynomial p of x equals x cubed plus 8x squared plus 21x plus 18 equals x plus 2 times x plus 3 to the second power. Has negative 2 as a zero once and negative 3 as a zero twice, or with multiplicity 2. The multiplicity of a zero of p of x, or a root of p of x, is a number of times that the related factor occurs in the factorization. In this Explorer, you will use algebraic methods to investigate the relationship between the degree of a polynomial function and the number of zeros it has. So A, find all zeros of p of x equals x cubed plus 7x squared. Well, what's the greatest common factor? It says factor out the greatest common factor. The greatest common factor is x squared. So what are the zeros of p of x? Well, if you set x squared equal to 0, that's going to give you 0 and 0. Think about it. Take the square roots of both sides, and you get x equals 0. And then what about the other x? X equals 0. And negative 7, because x plus 7 equals 0. Subtract 7 from both sides, and you get x equals negative 7. Find all zeros of p of x equals x cubed minus 64. Include any multiplicities greater than 1. So let's take a look at this. P of x equals x cubed minus 64. I'm seeing x to the third power minus 4 to the third power, right? So that's going to give x minus 4 times x squared plus 4x plus 16. Plus 16. What are the real zeros of p of x? Well, you've got x minus 4 equals 0, so x equals 4. So the real zero is 4. Now, x squared plus 4x plus 16, a while back we called that irreducible, which meant it didn't have any real roots. But it does have some complex roots, and the way to get those are with the quadratic formula. So x squared plus 4x plus 16 equals 0. So negative b, that's going to be 4 here. So negative 4 plus or minus 4 squared minus 4 times 1 times 16. 1 is the a, and that's right there. That's the 1. So that's going to be 2 times 1. do the arithmetic, and you get 4 squared is 16 minus 64 is going to give you negative 48. Negative 48. Negative 48. Well, are there any perfect squares in 48? I think 16 times 3 is 48. So, and 16 is a perfect square. So the square root of 16 is 4. So you're going to have 4. And you had a negative here, so bring the I out. You got negative 4 plus or minus 4i times the square root of 3 over 2. And if you look, you got a 2 here, and these two here have a 2 in them. So let's take the 2 out. And that gives you negative 2 plus or minus 2i, the square root of 3, all over 2. The 2's cancel out. And you end up with negative 2 plus or minus 2i times the square root of 3. So the non-real zeros of p of x are negative 2 minus 2i times the square root of 3 and negative 2 plus 2i times the square root of 3. All right, so how many? It said we had 3, right? And we found 1, 2, 3. That's 1, 2, 3. Good. C. Find all zeros of p of x equals x to the 4th plus 3x cubed minus 4x squared minus 12x. Include any multiplicities greater than 1. Well, I'm seeing an x in all of these terms. I'm seeing an x in all of these terms. All of them have an x, so we take an x out, and that's going to leave x cubed plus 3x squared minus 4x minus 12. So we factored out the greatest common factor. Group terms to begin factoring by grouping. So we're going to group the first two and the last two. And, I guess I should have put that one there. All right. X cubed. If we do that, that makes that a positive. Okay. So x cubed plus 3x squared minus, and that's going to be 4x plus 12. What's the greatest common factor in there? We have x squared. What's the greatest common factor in there? We have 4. So we're going to end up with x times x plus 3, and that's right here and right there, and then x squared minus 4. Now x squared minus 4, that kind of looks like, let's see, x squared minus 4, that's x squared, and that's 2 squared. So that's a difference of perfect squares, so that's going to give you x minus 2 times x plus 2. So what are all the zeros of p of x? Well, you're going to have 0, you're going to have negative 3, you're going to have negative 2, and you're going to have positive 2. Find all the zeros of p of x equals x to the 4th minus 16. I'm saying, let's see, x squared squared minus 4 squared. The difference of perfect squares again, so you're going to get x squared minus 4 times x squared plus 4. Well, x squared x squared minus 4. I'm seeing another perfect square in there, and that's going to give you x minus 2 times x plus 2. So what are the real zeros? We're going to have negative 2 and 2. Solve x squared plus 4 by taking square roots. So we subtract 4 from both sides, take the square root, and that's going to give you 2i. So we have negative 2i and we have positive 2i. Good deal. E, find all zeros of p of x equals x to the fourth plus 5x cubed plus 6x squared minus 4x minus 8. Include multiplicities greater than 1. By the rational zero theorem, possible rational zeros are, well, we're looking for the rational zeros of 8 right here, negative 8. So we got plus minus 1, 2, 4, and 8. Well, we get lucky. The first one we try is 1, and 1 gives us a remainder of 0. So 1 is a 0. So 1 is a 0. So you got x minus 1, and then that gives you x cubed plus 6x squared plus 12x plus 8. Well, we can still use the same factors because we're trying to find factor of 8. That's 1, 2, 4, and 8, plus or minus 1, 2. So we try 1 again, and we get 27. Negative 1, we get 1. Negative, or 2, we get 64. This time we try negative 2, and we get 0. So negative 2 is a 0. We have x minus 1 times x plus 2 times, and then this, remember it started out as x cubed, so this will make that x squared plus 4x plus 4. The quadratic is a perfect square trinomial. So we're going to have x minus 1 times, and that's going to be x plus 2. And let me show you, x squared plus 4x plus 4. That's going to give you x plus 2 times x plus 2. So you got 1, 2, 3. That's going to be x cubed. So what are the zeros of p of x? You got 1, and you got negative 2 with a multiplicity of 3. Okay, that's how they write it. You can write it out all the way or not. Complete the table to summarize your results from step A to E. We factored this one here, and we got x squared times x plus 7. So the real zeros, you got negative 7, and you got 0 with a multiplicity of 2. Non-real zeros, there were none. All right, x cubed minus, when we factor that, we got x minus 4 times x squared plus 4x plus 16. Real zeros, there was just one, and it was 4. So the other two were negative 2 minus 2i, the square root of 3, and negative 2 plus 2i, the square root of 3. Remember, these complex ones, they always come in pairs. And let's try this next one here. Remember, there was an x. We factored out an x, and then we got an x plus 3, and then we got an x plus 2, and an x minus 2. So we had 0, negative 3, negative 2, and 2. 1, 2, 3, 4, and 4. So there were none. That completely factored out. X squared, x to the fourth minus 16. We got x minus 2, x plus 2, and x squared plus 4. So we had 2 and negative 2. And then we had negative 2i and positive 2i. So we had 2 complex and 2 real for a total of 4. And that's 4. All right, good. This last one here, we had x minus 1 times x plus 2 times x plus 2 times x plus 2. It could be written as x minus 1 times x plus 2 to the third power. And that's kind of hard to read. Let me write that just right there. All right, so what are, we had 1 and we had negative 2 with a multiplicity of 3. And notice how the exponent and multiplicity, they work. And these had no or none complex. Reflect. Examine the table for each function. Count the number of unique zeros, both real and non-real. How does the number of unique zeros compare with the degree? Well, they equal each other, right? The degree equals the number of zeros. All right, the degree equals the number of zeros. Examine the table again. This time, count the number of zeros for each function, where a zero of multiplicity m is counted as m zeros. How does the total number of zeros compare with the degree? Perfectly. You have a certain number, or you have an n degree, and that is the number of zeros. The number of zeros. Describe the apparent relationship between the degree of a polynomial function and the number of zeros it has. Describe the apparent relationship between the degree of a polynomial function and the number of zeros it has. The number of zeros of a polynomial function equals the degree of the function when you include the complex zeros and count the multiplicities of zeros in total. So the relationship is they equal each other. Applying the fundamental theorem of algebra to solving polynomial equations. I'll give you a little bit of time to read that, stop the video, and when you come back, we'll do B together. Glad you're back. So B, x to the fourth minus 6x squared minus 27 equals 0. The polynomial has a degree of 4, so the equation will have exactly 4 roots. Notice that x to the fourth minus 6x squared minus 27 has the form of u squared minus u minus 6u minus 27. So where u equals x squared, where u equals x, so you can factor it like a quadratic. Okay, the way you do that, let u equal x squared. So you have 4 squared minus 6x squared minus 27. We're going to put this u in. We'll put the u in for the x squared. So we have u squared minus 6u minus 27. All right. So what are the factors of 27, negative 27, that when you add give you 6? That would be u minus 9 times u plus 3. And let's check that. Negative 9 times 3 is negative 27. Negative 9 plus 3 gives you negative, so that works. Now, let's put the x squared back in, and that's going to give you x squared minus 9 times x squared plus 3. Now, x squared minus 9, so x squared minus 9, x squared plus 3. Now, x squared minus 9, that's a difference of perfect cubes. So you got x squared minus, and that would be 3 squared. So that's a difference of perfect cubes. It's going to give you x plus 3 times x minus 3 times x squared plus 3 equals 0. The real roots are going to be negative 3 and 3. Solving x squared plus 3 equals 0, or subtract 3 from both sides, that gives you x squared equals negative 3. So x squared plus 3 equals 0. X squared equals negative 3. Take the square root of both sides, and that gives you x equals plus or minus the square root of negative 3. Negative 3. We'll write that a little bit better. Negative 3. Well, that becomes x equals plus or minus I times the square root of 3. So that's what we got here. I times the square root of 3. So the roots are I times the square root of 3 and negative I times the square root of 3. Great. Restate the fundamental theorem of algebra and its corollary in terms of the roots of equations. For every polynomial of degree, for every polynomial of degree n is greater than or equal to 1, the equation p of x equals 0 I messed that up. Has at least one root where a root may be a complex number. The corollary, let me write that in a different color. The corollary, and I'm just getting that off the other page there. The corollary for every polynomial of degree n is greater than or equal to 1, the equation p of x equals 0 has exactly n roots. When you include multiplicity. Great. Now let's take a look. It says your turn. Solve the polynomial equation by finding all roots. So you have 8x cubed minus 27 equals 0. And I'm looking here and I'm seeing, let's see, that's 2x to the third power minus, and that's going to be 3 to the third power. So that's a difference of perfect cubes. When you rewrite it, that'll give you 2x minus 3 times 4x squared plus 6x plus 9. So you have one real root here, 2x minus 3, and we already know that that's irreducible for real numbers, but there may be some irrational or complex number in there, so let's try that. And the way to do that is with the quadratic formula. So you got x equals negative 6 plus or minus the square root, and that's going to be 6 squared minus 4 times 9, all over 2 times 4. So it's negative b plus or minus b squared minus 4ac. We got some arithmetic to do. That gives you x equals negative 6 plus or minus 36 minus, and that becomes negative 108. I did it in the calculator, negative 108 all over 8. Well, negative 108, that's 16, or that's 36 times 3. So that's going to be negative 6 plus or minus 36. The square root of 36 is 6. So you got 6i, the square root of 3, all over 8. I think you can take a 2 out of that. So you got 2, and that's negative 3 plus or minus 3i, square root of 3, over 8, and these cancel out, and that becomes a 4. So your root, or your zeros, are going to be 3 halves. Your zeros are going to be 3 halves, and then we got that from there. And then you're going to have negative 3 plus 3i, the square root of 3, over 4, and negative 3 minus 3i, square root of 3, over 4. So 1, 2, 3. And that's what we had up there, was 3. Number 6. How do we start number 6? Look at it. First, you want to take out the greatest common factor, and that would be x. And that's going to leave you with x cubed minus 13x squared plus 55x minus 91. Now, 91, that's a big number. Fortunately, let's see here. What are the factors of 91? Plus or minus 1 and plus or minus 91. 9 and 1 is 10, so 3 won't go into it. It's not even, so 2 won't go into it. How about 7? Let's see. Plus or minus 7, and 7 goes into it 13 times, so that's plus or minus 13. And I can't think of anything else that goes in there. So we'll start off with 1. 1, and you got 1, negative 13, 55, and negative 91. So let's bring the 1 down. 1 times 1 is 1. That's going to give you negative 12. Well, that's going to give you negative 12. 55 minus 12, that's going to be 43. So that's going to give you 43 here. And that's going to give you negative 48. Not what we're looking for. All right. So let's see. If 1 don't work, let's try 7. Let's put a 7 in there. 7. Bring our 1 down. We got 1. 7 times 1 is 7. That gives you negative 6. 7 times negative 6, that's going to be negative 42. That's going to give you a positive 13. Well, 7 times 13 we already know is 91. So there we go. So we've got a 7 in there. So far we've got x times x plus 7. That's x minus 7. X minus 7. And then what is left? What is left? Well, we got x squared minus 6x plus 13. Now, 13, the only factors of 13 are 1 and 13, and you can't make 6 with that, so we're going to have to use a quadratic formula. We've got x equals, and that's negative 6, plus or minus the square root of negative 6 squared minus 4 times 1 times 13. All over 2 times 1. So x equals, and that's going to be 6 plus or minus the square root, and negative 6 squared, that's going to be 36, minus 4, and let's see, 4 times 1 is 4, 4 times 13 is 52. So you got 36 minus 52, I believe that's negative 16. So that makes that negative 16 all over 2. Well, negative 16, that's going to give you 6 plus or minus. The square root of 16 is 4, and the square root of negative 1 is I over 2. And I believe you can take a 2 out of that. So you got 2, and that's going to be 3 plus or minus 2I over 2. Those cancel out. And you're just left with 3 plus or minus 2I. So our zeros are going to be, we had x, so our zeros are going to be 0, zeros are going to be 0, 7, 3 plus 2I, and 3 minus 2I. Good deal, good deal. And there's our roots, or zeros. Writing a polynomial function from its zeros. The irrational root theorem. If a polynomial p of x has a rational coefficient and a plus b times the square root of 3, square root of c is a root of the equation p of x equals 0, where a and b are rational and the square root of c is irrational, then a minus b times the square root of c is also a root. Complex conjugate root theorem. If a plus bi is an imaginary root of a polynomial equation with real number coefficients, then a minus bi is also a root. All right, I'll let y'all read the rest of that. Do example A, and when you come back, we'll do example B. Two, 3, and 1 minus I, because complex zeros come in conjugate pairs. 1 plus I must also be a zero of the function. Use the 4 zeros to write a function in factored form. Then multiply to write it in standard form. So you have x minus 1 plus I times x minus 1 minus I times x minus 2 times x minus 3. So how do we multiply this big old thing? Well, you got to follow along here. You got x times x, that gives you x squared, right? And then we have x times negative 1 minus negative, that's going to give you minus 1 minus I times x. And then you're going to have negative 1 minus times x. So that's going to be minus 1 plus I, and I got that right there, times x, plus, and then of course the last would be 1 plus I times 1 minus I. That's a minus and a minus, that makes that a plus, and then 1 plus I and 1 minus I, times x minus 2 times x minus 3. This looks a whole lot more complicated than it really is. You do a couple of them, you'll have it down pat. So here, and if you notice, these are, well, we'll do those in just a second. Let's do these right here. You got 1 times 1 is 1, and then you have, let's take this over here. 1 plus I times 1 minus I. That's 1 times 1 is 1. 1 times negative I is negative I. I times 1 is positive I. And I times I would be I squared. So these two here are going to cancel each other out. And you got 1 minus, and then I squared. That's I squared is negative 1 by definition. So you got 1 plus 1, which is 2. So we're going to put in here, we're going to put 1 minus negative 1. Okay, and then you'll notice here that becomes 2. This has an x and that has an x. So they decided to put them together. So you got 1, negative 1 plus I minus 1 minus, okay, so negative, this right here, negative times, that's gives you negative 1, and then negative times negative I, that gives you positive 1. And then here you got negative 1, negative 1. They're distributing that negative in there. First they distributed that, now they're distributing it here. That's going to give you negative 1, and negative times negative, that's going to give you minus I. So if you'll notice, these two i's, they cancel out, and you got negative 1 minus 1, so you got x squared. Negative 1 minus 1 is minus 2. And multiply that by the x, negative 2x, and then you got negative 1 plus 2, negative 1 plus 2. Oh, that's negative, let's see, negative 1, we did those, and got negative 2x, and then you got the plus 2 left there. X minus 2 times x minus 3. So this gives you x squared minus 2x plus 2, and then x minus 2 times x minus 3. X times x is x squared, and the x, that's going to be minus 3x. That's going to be minus 2x, and that plus 6. So you got x squared minus 5x plus 6. That's what goes in here, x squared minus 5x plus 6. Now they're going to distribute, they're going to multiply this times that, and I'm going to move to the next page before I do that. So we'll put this back in there. That's x squared minus 2x plus 2 times x squared minus 5x plus 6. X squared times x squared, x squared times that, and then negative 2 here times that, and then positive 2 times that. X squared times x squared is x to the 4th, x squared times, and then so on. They distribute inside it, all of those. Now let's combine like terms. So we got x to the 4th. Do we have any other x to the 4th? No. So that gives you x to the 4th. You got minus 5x cubed. You got minus 2x cubed. And are there any other x cubed? No. So that's minus 7x cubed. And now we have 6x squared plus 10x squared plus 2x squared. 6 and 10, that's going to give you 18x squared plus 18x squared. And moving right along, we go to minus 12x minus 10x. That's going to give you minus 22x. And then all that's left is your 12 plus 12. The polynomial function is p of x equals, and that's going to be x to the fourth minus 7x cubed plus 18x squared minus 22x plus 12. Restate the irrational root theorem in terms of the zeros of polynomial functions. If a polynomial function p of x has rational coefficients and a plus b times the square root of c is the zero of the function where a and b are rational and the square root of 3, the square root of c is irrational, then a minus b times the square root of I is also a zero of p of x. So that was the irrational root theorem. Basically, it says they come in conjugate pairs. They come in pairs. So if you have a plus b times the square root of c, you will also have a minus you'll also have a minus b times the square root of c. They come in pairs. Restate the complex conjugate zero theorem in terms of roots and equations. If a plus bi is an imaginary zero of a polynomial function, p of x equals p of x with real number coefficients, then a minus b is also a zero of. So what they're saying is a plus bi. If you have one of those, then you'll also have an a minus bi. They come in pairs. Oh, it's about to get fun now. Write the polynomial function with the least degree and a leading coefficient of 1 that has the given zeros. So you have 2 plus 3i and 4 minus 7 times the square root of 2. So what does that mean? Well, if you have 2 plus 3i, you're also going to have 2 minus 3i. If you have 4 minus 7 times the square root of 2, you're also going to have 4 plus 7 times the square root of 2. Okay, so you're going to have 4. So your end formula will have a degree of 4. Now, how do we redo this? How do we reverse this process? Well, it was a lot like what we did just a minute ago. Okay? So we're going to have, and it's going to be x minus, and then you got 2 plus 3i. And that's going to be multiplied by x minus, and then you got 2 minus 3i. And that's going to be multiplied by x minus, and you got 4 minus 7 times the square root of 2. And that's going to be multiplied by x minus, and you got 4 plus 7 times the square root of 2. Okay, now this is kind of complicated. Just stick with me, okay? And I'll try my best to color code stuff. So we've got x times x, and that's going to give you x squared, right? Then we're going to x times FOIL, right? The minus. So that's going to be minus x times 2 minus 3i. Then we're going to do the inner, and that's going to be, we got a negative there, so we got minus x times 2 plus 3i. And then we're going to do the last, and that's going to be 2 plus 3i times 2 minus 3i. And so we got a negative and a negative. That's going to give you a positive, and that's going to be 2 plus 3i. 2 plus 3. Let me clear that up. 2 plus 3i times 2 minus 3i. And we're just going to stick with this part here for now. We'll do it, and then we'll do the other half. So we got, what do we got here? We've got, I like to go ahead and do the arithmetic. So that's going to give you x squared, and then that's going to be minus 2x, and then it's going to be plus 3ix, negative and negative. Minus 2x, and then minus 3ix. Okay, so good so far. And then this right here, you got 2 times 2, that's going to be 4. 2 times, that's going to be minus 6i. And then 3i times, that's going to be plus 6i. And then that's going to be minus 3 times 3 is 9. I times I is I squared. Okay, now if you look, you got x squared. Now let's combine some like terms here. You got minus 2x and minus 2x. Do you have any other? No. This is, you've got plus 3ix minus 3i. So those are going to cancel out. You also have minus 6i and plus 6i. Those cancel out. So you got x squared minus 2x, that's going to be minus 4x. All right, so that's them. So we've got this. We've got 4 plus 4, and then minus 9, and that's I squared. That's like negative 1. Okay? So that's going to give us x squared minus 4x, and that's going to be 4 minus 9 times negative 1. That's going to be 4 plus 9. That's going to give you plus 13. Okay, so yeah, it was pretty long at first, but we hung in and we're down to there. Now let's go over here and do the second half. First times first, that gives you x squared. Then we have outer times outer, and that's going to give you minus x times 4 plus 7 times the square root of 2. All right, good. Then we have inner, and that's going to be these two here. And you got a negative and a positive, so it's going to be minus x times 4 minus 7 times the square root of 2. Okay. And then we got last. We got these two here. You got a minus and a minus, so that's going to give you plus 4 minus 7 times the square root of 2 times 4 plus 7 times the square root of 2. Again, that looks a lot longer. What do we got here? We've got x squared. And then do the arithmetic. That's going to be minus 4x, and then minus 7x the square root of 2. Over here we've got minus, that's going to be minus 4x, and then negative, that's going to be plus 7x, the square root of 2. And if you'll notice, these two here, they're going to cancel each other out. And we're left with the last minus 4x. Yeah, we're left with the last part over there. So we're going to have plus, you got 4 times 4, that's 16. And then 4 times 7, that's going to be plus 28, the square root of 2. And that's 4 times that. All right. And then inner, that's going to be negative, and that give you minus 28, the square root of 2. And those two there, they're going to cancel each other out, plus and minus, and you're left with last, and it's going to be minus 49, the square root of 4. Okay. Now we can clean that up some. And that's going to give you, and that was x squared, x times, that's x squared. So we got x squared minus 4x. Combine those, and it gives you minus 8x. So that's all of that. And it gives you plus 16. And we've got that. And then we've got this right here. And that's going to be, what's the square root of 4? That's 2. So that's going to be minus 49 times 2. Okay. So we end up with x squared minus 8x, and then 49 squared, or 49 times 2 is 98, negative 98. So you got 16 minus 98, and that's going to give you minus 82. Now we just have to multiply these. And we've got x squared times x squared, that's going to be x to the 4th. X squared times minus 8x will be minus 8x cubed. Then x squared times minus 82 will be minus 82x squared. Now let's do minus 4x times x squared. That's going to be minus 4x cubed. 4x times negative 4x times negative. That's going to be plus 32x squared. And then 4x times negative 4x times negative 82. That's going to be plus, and then 4 times negative 4 times 82. That's going to be 328x. 328x. And let's see, 82, 4. That's going to be 8, and that's 300. So yeah, that is 328x. 328x. Good. And let's do the last one. You got 13 times x squared, so it's going to be plus 13x squared. 13 times negative 8x. 13 and 8, that's 24, 2, 8, 9, 10, 104. So it's going to be plus 104x, and that's a plus and a minus, so that's going to be a minus. Now you got 13 times 82, and it's going to be negative. So 82 and 13, that's 6, that's 24, and that's 82. I got 6, 1066, 10, so it's minus 1066. All right, good so far. Now we've done all the multiplication. All we got to do is the simplification. So let's see here. We've got x to the 4th. Any other x to the 4th? No. So we got x to the 4th. The next one would be x cubed. minus 4x cubed. Any other x cubes? Nope. So we got minus 12x cubed. And let's see what we got here. Negative 82x squared plus 32x squared plus 13x squared. Any other x squareds? No. So negative 82 plus 32, that's going to give you negative 50. Negative 50 plus 13 will give you negative 37x squared. Good. All right, so what do we got here? We got 328x minus 104x. So that's going to be 224x, and that's going to be positive 224x. And then all we got left is the minus 1066. There we go. We did good. There it is, 1066. Good deal. Solving a real-world problem by graphing polynomial functions. Go ahead and stop the video and read all that, and when you come back, we'll do B. We'll do B together. All right, glad you're back. Find a single polynomial model for the situation in example 3a, whose 0 represents the time that oil consumption for the Asia-Pacific region overtakes consumption for North America. Plot the function on a graphing calculator and use it to find the x-intercept. A difference of 0 indicates the time that consumption is equal. The time that consumption is equal. So we have CP of T, and then consumption of AP, Asia Pacific of T, minus the consumption of North America of T. So what do we got here? Some serious numbers. Remove the parentheses and rearrange the terms. So if this is this, I'm going to distribute the negative. That's going to be minus 0.00494 t to the fourth. Negative times, that's going to be plus 0.0915 t to the third. That's going to be minus 0.442 t squared. That's going to be plus 0.239 t, and it's going to be minus 23.6. All right. So t to the 3, we got a t to the 4. So that's going to start off and negative 0.00494 t to the 4 plus, and then we got, let's see here, t to the third and t to the third. So we're going to add those two there. And that's here and here. And then, let's see, minus t squared, minus t squared, okay. So we got to put those two together. And we got 1.23t and 0. So we got to put those together. And then, of course, the constants. We got to put those together. Combine like terms, round to 3 significant digits. So we start off right here at negative 0.00494 t to the fourth. And then we're going to add those. Plus, and I did it on the calculator, plus 0.1 t to the third. And that was supposed to be in t to the fourth. That was the first term, t to the fourth. And then we did red. We're going to put those together, and it's going to give you negative 0.581 t squared. And then put the t's together, and that's going to give you plus 1.47 t. And then we put the last ones together, and that's going to give you minus, it looks like minus, I'm thinking minus 2.5. Okay. Let's see. At 23.6, 21.1. So that's giving me a 5, and that gives me a 2.5. Okay, good. Negative 2.5. So what do we got here? Graph C of t and find the x-intercept. The graph with y min equals negative 4 and y max equals 6 is shown. With the rounding error, the results for the x-coordinate and the y-coordinate are the same. And x is 5.349. Right, good. Your turn. An engineering class is designing model rockets for a competition. The body of the rocket must be cylindrical with a cone-shaped top. The cylinder part must be 60 centimeters tall, and the height of the cone must be twice the radius. The volume of the payload region must be 558 pi cubic centimeters in order to hold the cargo. Using a graphing calculator to graph the rocket's payload volume as a function of the radius x. On the same screen, graph the constant function for the desired payload. Find the intersection to find x. So what do we got here? The overall volume will equal the volume of the cone plus the volume of the cylinder. The volume of the, that looks terrible. Volume of the cylinder. All right, good. So the volume of the cone is going to be the volume of the cone will be, that's going to be 1/3, because it's a cone, it's going to be 1/3, 1/3 pi, and it's usually pi r squared, but it'll be pi x squared, and then it's supposed to be 2x, right? Times 2x. Okay, good. And then the volume of the cylinder, boy, I'm not doing a good job. Volume of the cylinder. The volume of the cylinder is going to be, again, you got pi r squared or pi x squared, and then it was going to be 60. 60 is what we had in here, wasn't it? 60 centimeters tall. So that's the height. It's pi r squared h for the cylinder, and it's pi r squared, and then h for the cone. All right, so now we got that. So the volume of x will equal 1/3 pi, and then x squared times 2x. That's, well, we'll just do it. X squared times 2x plus pi x squared times 60. Wonder what's going on in the background here with Windows. X squared times 60. Maybe I just need to slow down, huh? So the volume of x, and we got a little arithmetic. 2 times 1/3, that's going to give you 2. What it is, it's lag. 2/3 pi, and x squared times x is x cubed plus, and that's going to be 60 pi x squared. Good. So now we need to graph that. So we'll graph that. And remember, the volume of x, the total volume was, it said 558 pi. 558 pi. So we need to graph both of these. Let's go to our trusty, rusty calculator. And we have, the first equation was 2 control divide 3, and that's going to be pi x cubed, x caret 3. And then we want to add that to the cylinder, which is going to be pi x, 60 pi x squared, 60 pi x squared. And let's graph that. Wow. Okay. And then we also want to graph the second equation, and I believe that was 558 pi. 558 pi. So 558 pi. Good. Now that's going to be way up here somewhere, right? That's going to be way up here. Is there a way to get there quicker? Sure. Menu, 4. Okay. Now let's see here. Put escape, menu, and then window, and then 1. So x min, we'll just make that like -5, and we'll make x max 5, and we'll hit 1. And let's see if that keeps us on there. Oh, it does. So there it is right there. So we're not really worried about this because that would be negative, and our volume cannot, or our dimensions can't be negative. They have to be positive. So menu, 6, 4, and what is that? That's 3 and 1.75. Okay, and then if you go over here, menu, and it's going to be -3. Yeah, see, -3, and well, that's -3.1. Either way, it can't be negative. It's got to be positive. It has to be positive. So because the radius has to be positive, the radius of the rocket, the radius of the rocket is 3 centimeters. Would y'all like to put these together and do the math and whatnot? Oh, okay, well, all right. I got you. Uh, let's see here. Y'all don't want to do that. I got you. What does the degree of a polynomial function p of x tell you about the zeros of the function or the roots of the equation of p of x equals 0? The degree tells you how many roots there are. The degree tells you how many roots there are. All right. Number 12. A polynomial equation of degree 5 has roots 0.3, 2, 8, and 10.6, each with a multiplicity of 1. So that's 1, 2, 3, 4. What can you conclude about the remaining root? Well, it must be rational. It must be rational. How do I know that? Because irrational and complex roots only come in pairs. And since these are all rational, the fifth one must be rational. Describe 2 ways you can use graphing to determine when 2 polynomial functions that model a real world situation have the same value. Describe 2 ways. Well, you can graph both functions on the same coordinate plane and find the points of intersection. Graph on same plane and find point of intersection. That's one way. The other way is you can combine them. You can combine them and find the difference between them, and then where they cross the x-intercept is where the x value of the point of intersection will be. So you can find the difference. You can find the difference of the 2 functions, graph it, and then the x-intercept will be the x value where the original functions intersect. Essential question: what are possible ways to find all the roots of a polynomial equation? The degree gives you the number of roots. You can factor when possible and use the rational root theorem and zero product property to find rational roots. Then you can use the quadratic formula to find irrational or complex roots. So the degree gives you the number of roots. And then, like I said, you can use the rational root theorem or the zero product property to find the rational roots. So then find the rational roots And if they don't add up to the degree, then use the quadratic formula to find the irrational and or complex roots. All right, good deal. Great lesson. Have a good evening. Tomorrow we'll meet and work on homework. Thank you for your time.